we know the rate of change of a quantity, we can use definite integration to understand the net change of that same quantity. So let's take a look at this question. The rate of change in the population of a certain town is given by the function pop, which is a function of t, and the function is given by 0.6 t squared plus 0.2 t plus 0.5. So this is the rate of change of the population. Here pop, and the function pop is measured in thousands per year, and t is measured in years. The water pollution is known to be measured to be 5 units for every 1,000 people in the town. What will the net change of the pollution of the town be over the next 2 years? So as I mentioned, we can get the net change of a quantity, so we can get the net change in the pollution if we know the rate of change of the pollution. So here we're given the rate of change of the population, so how can we figure out the rate of change of the pollution? So the rate of change of the pollution, I'll say write as the function pol, and the pollution is 5 units per 1,000 people. And here we have the population function, the rate of change of the population given in thousands per year. So what I can do is I can multiply this function, which is the rate of change of the population, by 5 units, which will give me the rate of change of the pollution. So 5 times pop as a function of t. And once I carry out that multiplication, that ends up being 3t squared plus t plus 2.5 units of pollution per year. So this is the rate of change of pollution. So now I can use the definite integral to calculate the net change in the pollution, because now I have a function that represents the rate of change of the pollution. So to calculate the net change, so the net change from t equals 0, which is right now, until t equals 2 years from now, will be the definite integral from 0 to 2, because I'm going from now. I want the net change from now until 2 years from now. And the function that is the rate of change of the pollution is given, I just calculated it, it was 3t squared plus t plus 2.5, and I'm going to integrate that with respect to t. So now if I just carry out this definite integral, I can calculate the net change in pollution over the next 2 years. So to do that, I'm going to use my definite integral rules, which allow me to break this definite integral up into 3 separate integrals. 0 to 2 of t dt plus 0 to 2, 2.5 dt. And I also have a rule that allows me to remove any constants that are multiplying the functions inside my integrand. So I can take this 3 out. So this becomes 3, 0 to 2 t squared dt plus, this doesn't change, 0 to 2 t dt, and this doesn't change either, 0 to 2 times, or the integration of 2.5 dt. Now I'm in a situation where I can actually use anti-differentiation formulas to calculate the antiderivative of this. So this becomes 3. The antiderivative of t squared is 1 over 3t cubed, and I'm going to go from 0 to 2, plus the antiderivative of t is 1/2 t squared, I'm going to go from 0 to 2, plus the antiderivative of 2.5 is 2.5t, and I'm going to evaluate that from 0 to 2. So now I can go ahead and plug in my endpoints. So this becomes 3 times, plug in 2, 1/3 2 cubed, minus plug in 0, 1/3 0 cubed, plus plug in 2, 1/2 2 squared, minus 1/2 0 squared, plus plug in 2, 2.5 times 2 minus 2.5 times 0. Okay, I can simplify this. This 3 will actually cancel out with both of these 1/3, and of course 0 cubed is just 0, so all I'm left with in the first part here is 8. If I look over here, I have 0 squared, so that's just 0, so that'll go away. But I have 1/2 of 2 squared. 2 squared is 4. 1/2 of 4 is 2, so that becomes plus 2. If I look over here, I have 2.5 times 2 minus 2.5 times 0. 0 times 2.5 is just 0, so I'm left with plus 5. And so my final answer is 15 units. So this says that the net change between now and 2 years from now in the pollution of the town is going to be 15 units.